So today I want you to be able to simplify and evaluate expressions using properties of logarithms. And then on the back side of today's notes, we are going to learn how to solve logarithms using the properties of logarithms that we're learning here on the front side. Okay, so let's start by talking about how is there a connection between logarithms and exponents. And we already learned that last week, but we're going to show you now an example. So let's rewrite both of these. And if you look over there on the chart to your left, starting at the very top, which row is the first row that contains a 9 and an 81? It would be base 3. Does everybody see that? So I can rewrite 9 as 3 squared, and I can rewrite 81 as 3 to the 4th. You're going to want to be writing this all down, and I apologize that we have to go so fast today. Because we took the quiz, we took time to study, we're just really going to have to move fast here. When you have the same base and you're multiplying, you're going to add the exponents. 2 plus 4 is 6. What is this saying? If you took a calculator, 9 times 81 is 729. And if you plugged in 3 to the 6th, it is also 729. It's two alternative ways to write the same value. Now, how does this relate to logs? So I'm going to take this, and what we're going to learn down here is that this is right now, it's condensed. If you condense something, you push it together. If you expand it, you pull it apart. Do you guys already know that? This is condensed. When we expand this, multiplying turns into addition. So it's log base 3 of 9. Turn this into addition. Log base 3 of 81. Now I'm going to rewrite this 9 like we saw it up above. Log base 3 of 3 squared plus log base 3 of not 81 but 3 to the 4th. Last week we learned that when these are the same numbers, the log, and in this case, the base 3 and the 3 cancel, I bring down the 2. The log and the 3 and the 3 cancel, I bring down the 4. And 3 plus 4 is 6. So watch. Log base 3 of 9 times 81, I'm getting that from this portion, is equal to the answer of 6. For most people, that's not making sense. So here's what I'd like you to do. Think of this in terms of disco, unless disco doesn't make sense to you. If it doesn't make sense to you, remember we start with this bottom number of 3. We push up the 6, and we set it equal to 9 times 81. I've already told you that 9 times 81 is 729. Take 3 to the 6, see if it's equal to 729. Yes or no? Okay, so this is how it relates. Here's how the properties of logarithms and exponents relate. Going down to number 2. So I already explained this in the problem up above, but when you have in parentheses 2 quantities and they're being multiplied, that's condensed. To expand it, we're going to write 2 forms. Remember to take the log base 3 for both, and I have one has a 4 and one has a 7. The multiplying turns into addition. Done. So I just want to write that down. When you have multiplying and you are expanding it, it turns into addition. Likewise, when you have division and you expand it, it turns into subtraction. We'll get to those problems down below. Here's an example of a type of problem you have in your homework, number 3, where you don't need a fancy calculator. Like a dollar calculator would work just fine. It tells us that you're going to have to use this fact. And they want you to approximate this value. We can see they have the same base, but 3 is not the same as 48. So the first thing is, we're going to take this and we're going to rewrite it. So log base 2 of 48. I want to take it and I want to rewrite that 48. And your hint is to come back to what they gave you. So please take 48 and divide it by 3 and tell me, is it a nice whole number? It's 16? Okay, so let's write 16 times 3. Once again, I took this value and I divided it by the given number behind the base. Okay, so notice the base is 2. Please look up at the chart to your left. How can I rewrite 16 having a base of 2? Okay, let's write 2 to the 4th times 3. Now I'm going to expand this. The multiplying turns into, anyone? Addition. I have log base 2 of 2 to the 4th. And then this turns into addition, log base 2 of 3. You already know this answer because it was given to you in the problem. And here's the approximate value of it. And last week we learned that log base 2 of 2 cancels, we bring down the exponent. So 4 plus this quantity would say log base 2 of 48 is approximately 5.5850. I just added 4 to this number. One through 5, raising your hand high since I am currently seated. How well did you understand that problem? Totally fine to be 1s and 2s. Most of us are in a range of 2 to 4. Okay, we're going to go on to the next one. 4 says you understand that condensed, multiplying, and division. Now, when we expand the condensed form, turns into addition and subtraction. They give us these two values. Circle them, please. They want us to use these two facts to find this answer. So log base 3 of 4. Well, how can I rewrite 4, keeping the same value, but using what they provided me? I can go log base 3 of 20 divided by 5. Where am I coming up with those numbers? Like, why couldn't I take 8 divided by 2? Or 16 divided by 4? I have to take what they provide me with, okay? So right now I have division, and it's condensed. Let's expand it, so log base 3 of 20. Now instead of writing division, it's subtraction, log base 3 of 5. You know these two quantities because they're already provided for you. So do me a favor, take this quantity, subtract this quantity, and you have 5 seconds to get the answer. Go. Last period, I ended up with 1.2618. Does anybody else have that? Nobody has that. Raise your hand if you have that value. Okay, not enough hands went up. Either I didn't provide you enough time or there's some confusion. Can you go back to your partner and see if you can help them or they can help you? Here's an additional 20 seconds. Go. Is it time or is it understanding? Okay, thank you. Does anybody have any questions for me about number 4? Please ask if you do. Yes, thank you, Esme.
We just needed to subtract the
And subtract in the order they asked. So you're going to subtract this quantity first, subtract this quantity second. And I'm writing approximately because the numbers we were given were approximate. They were rounded answers. Okay, here we go. We are going to skip 6. We'll do 5, but we're going to skip 6 for time purposes. You do not have a word problem on today's homework. Dealing with properties of logs. We'll come back to it tomorrow. We'll start with like a bell work with this problem, but for today we don't have time. Okay, so again, we're given these values and we're asked to find log base 4 of 36. So I focus on this number. How can I use 6 to get to 36? So there's a couple different ways we can do it. Here's the way I prefer. Actually, I'd like to show you 2 ways. Do you agree I could do 6 times 6? Okay, that's a longer way. I want to show you 2 ways. So then I'm going to break it apart. So multiplying turns into, anyone? Addition. And you could easily add these 2 values twice. Everybody good with that? Here's an alternative. There's nothing wrong with that. Here's an alternative. I also know that log base 4 of 6 squared, this quantity is equal to 36. Last week you learned that if you have an exponent, it can jump in front of the log and be written as, in this case, 2 times the log base 4 of 6. In that case, we know this quantity, and we're going to take it times 2. That's the same thing as adding the quantity twice. Either way, you should get an answer of log base 4 of 36 is approximately 2.585. Let me move that over so the camera can see. Whether you use the top or the bottom, you should get the same answer. Please check on your calculator to confirm with me. Once you agree, then you're going to flip to the back side. Esme, thank you for asking that last question. Does anybody else have questions on 1 through 5? Again, we're skipping 6, we'll come back to it tomorrow. Anybody? Okay, on the back side is the second learning objective. How can we use properties of logs to solve equations? Most students like these because they're just manipulating numbers. It's very procedural. Okay, this is expanded. How do you know it's expanded? You have a log base 5 separated by adding or subtracting, and a log base 5 again. So when I condense it, what does the subtraction turn back into? Division. But before I do this, do you notice how there's a 3 out front? So I'm going to turn that back into the exponent. So log base 5 of x cubed subtract log base 5 of 4 equals log base 5 of 16. For time purposes, I am going to speed up. The subtraction now turns into division. Log base 5 of x cubed over 4 equals log base 5 of 16. Now we have log base 5 on both sides, separated by an equation symbol, and there's no additional numbers. That means we can cancel this out. And now I'm solving, I'm going to come off to the right where I have a little more room. I'm solving x cubed over 4 equals 16. There's a couple different ways to solve this, so we talked about this in a previous period. Here's one way. Throw a 1 underneath the 16. I'm going to cross multiply. X cubed times 1 is x cubed. 16 times 4 is 64. And that statement says, what raised to the third power equals 64? Remember to eliminate the 3, and remember, really when you eliminate it, it's turning back into a 1. But we're going to raise both sides to the 1/3. That cancels, again, kind of turning it back into a 1. And 64 to the 1/3 power, you can plug it in the calculator, or you can look off to the side, is an answer of 4. The one thing from last week you have to remember, it was in your notes, but we're really hitting it hard now that we're solving equations. Does everybody see this position behind the log base? That number can never ever be a negative. So when I plug in 4, it's not negative, we're good to go. Okay, we're going to go on to the next one. For this problem, I'd like you to change this from subtraction to addition. I made a mistake, so it should have been addition. So we get to practice that way. The previous problem was subtraction, now we're going to practice with addition. There's no numbers out front, so I don't need to turn them back into exponents. Log base 4. When I condense this, addition turns into, so I have x times x minus 6 equals 2. Now, whether you understand the disco move or you prefer looking at it like this, that's my bottom number, and I'm going to push up the 2. Okay? 4 raised to the second equals x times x minus 6. 4 raised to the second equals x times x minus 6. I'm going to distribute the x. And now I'm going to move everything to the same side. So I'm going to move the 16 over to the right. When it moves across the equal sign, it becomes negative. Bottoms up, what multiplies to equal negative 16 and combines to give you a negative 6? X equals 8, x equals negative 2. You have to check them. Okay, so I'm going to start with 8. If I take an 8 and I plug it in here, I have not broken any math. It's still positive. If I take an 8 and I subtract 6, it's still a positive. This answer works. When I take a negative 2 and I plug it into this position, it's negative. Can't work. Extraneous solution. Okay, moving on to C. There's no exponents because there's no numbers in front of the logs. This is currently expanded and has subtraction. So when I condense it, subtraction turns back into division. We have a log base 3 on both sides. There's no additional numbers, so I can go ahead and cancel them out. And now I have 42 over x equals 7. And there's different ways to do this. I'm going to write a 1 underneath 7. And I'm going to cross multiply and solve. 42 times 1 is 42. X times 7 is 7x. Now we're going to check. So I take a 6, I plug it in to the number behind, for a variable, in the position behind the log base. It's not negative, this works. D is like B. D is like B. I'm going to ask that the entire time you're working with your partner, obviously unless you don't have a partner. So I should hear you talking. I'm going to give you 1 minute to do D, and then when you're done, you're going to check your work with mine. So don't look up until you're done unless you're confused. Ready? Get set, go. Really? Are you guys going to try? Brenda, Trinity? Does anyone have questions for me about what I have? I know we're moving through this pretty fast. Anybody? Okay, we're going to go on to option E. Now, option E looks a little different. And that's because you're like, well, it doesn't really look expanded. There's only one property that expands it here. And that's this 2. Draw an arrow from the 2 to the area where the exponent would be on the x. We're going to rewrite this. Sorry, made it a little confusing there. Because we have a log base 7 on both sides, we don't have any additional numbers, we can cancel those out. Note that because you are solving for x and there's a square, how many answers should you have? 2. So how do you get rid of the square? You can raise it to the 1/2 both sides or square root both sides. But you should get 2 answers, positive 5 and negative 5. Excuse me. When you substitute positive 5 in for x, we're not breaking a math rule, but when you substitute negative 5 in for x, this cannot be a negative number. And our final problem, F. Again, please draw an arrow. So the 1/2 becomes an exponent on the x. We have log base 4 on both sides, so I get to cancel them out. Now, what do I raise both sides to so I can eliminate the 1/2? Raise it to the reciprocal, which is a 2, or a square. Remember, when it eliminates, really it turns into a 1. Okay, so 12 squared is 144. I check it, and it works. That's our answer.